Hello and welcome to Wednesday's edition of Cracking the Cryptic, where I think I need to start today's video with an apology. I know some of you will have been hoping to see Marty Sears' Rat Run Sudoku number 38 in this incredible series that he's gifted to the puzzle-solving world. And you may be thinking, Simon, you always do this on Wednesdays. You're right, I do if I possibly can. But today I'm actually meant to be on an aeroplane. So, well, today for you, I'm meant to be on an airplane. So this is one of those rare occasions where I have to pre-record the video. And of course, the Rat Run puzzle isn't released until the day. So I can't actually solve it because I don't know what it is yet. So with apologies to Marty and to you guys if you've been waiting for that puzzle. We are instead going to have a look at a puzzle by Jonesy, and Jonesy's puzzles are fantastic, so I'm sure we're not going to be disappointed with this one. It's called Balance Lines. It's been recommended to us. Apparently it is lovely. The rule set is very I think I've seen a rule set like this before, perhaps even from Jonesy. But the basic idea is that the sum of the odd digits on a line is equal to the sum of the even digits on the line, which is an amazingly simple concept. But that is what we have to do in the puzzle. Now, of course, there are other rules as well, and I will trot through those, make sure that we all understand them properly before we kick off and try and solve the puzzle. But that's our job today. I think this one's got 3 stars out of 5 for difficulty. And we'll read the rules together in a moment or two. Now, before we kick off, I've done my apology. What else can I tell you about? Today is the 20th of the month, and that means it is the final day of our Patreon reward. This was the Spider-Man Sudoku hunt. It's been available since the 1st of May, and 8 puzzles in all. If you haven't started yet, could you finish them by the end of play today and get your answer in? The answer is definitely yes. Providing you do, I think it will take most people 2 or 3 hours to solve. So, yeah, you probably, if you're an absolute whiz, you can do it quicker. If you're tan die, you probably only need half an hour to do all 8. But if you're more normal, it will, I think, take you a few hours. But if you get your entries in any time roughly, so that it's still the 20th in any time zone on Earth, we always accept the entries, and give yourselves a chance to win the opportunity to come onto the channel and solve a puzzle. That would be great. I have got birthdays to do. Now, I do apologise because I am recording this in advance. If you've only let us know that you'd like the birthday shout out very recently, then I might not have got the message. I will try and catch them up, obviously, in the coming days. But I apologise if I'm missing your birthday. But the following people did write to me in time. So, Josh, you're turning the big 3-0 today. And I know this because your wife, Vanessa, wrote to me and said that you might like a shout out. I think you watch at night before going to bed. So Vanessa says she hopes you sleep well. I don't know. Is it too late to have chocolate cake if you're watching this when you're going to bed? I don't think so. It's never too late for chocolate cake. Josh, go and find some chocolate cake, and hopefully it's very heavily iced. And also, birthday for tomorrow for T. Matty. From your fiance Aidan. Now, T. Matty is an absolute stalwart of our blueprint streams every week. Well, thank you so much, firstly, for all your support there and for watching those videos, T. Matty. Tyler in real life, I know. And I hope that we will have continued to progress on Monday. I am actually recording this before. This is so confusing to do. I'm sort of having to project myself into the future. I hope we continued to progress after our escapades with the cipher. And yeah, T. Matty, many happy returns. I hope you have a brilliant birthday, and I hope the chocolate cake is exceptionally well iced, of course. I think that's all the news. Shall we have a go at Balance Lines by Jonesy? Let's read the rules together. The rules start with the word hello. We have normal Sudoku rules applying, so we're going to have to put the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. Then, on each line, this is the thing I mentioned at the start, on each line the sum of the odd digits equals the sum of the even digits. So on that line, imagine, this will be difficult to do, won't it? If that was 3 and that was 7, then the even digits could be 2 and 8. The odd digits would add up to 10, the even digits would add up to 10, we would be in equilibrium. There aren't many more rules. Digits separated by a white dot consecutive. So if this was a 3, this would either be a 4 or a 2 to be consecutive with 3. And the digit in the grey square, which is only that one, must be even. And they are all the rules. Do have a go. The way to play is to click the link under the video as usual. But now, I get to play. Let's get cracking. Now well, okay, there's a couple of things I'm wondering about here. The first is this a colouring puzzle? i.e., are we going to be shading for parity? It seems very likely, doesn't it? But the other thing, and this perhaps is more fundamental, is that if we think about the nature of any line in this puzzle, it's going to have some even digits on it. Because you can't make, if it didn't have any even digits, the odd digits on it would have to sum to 0, and that's going to be difficult. So the even digits on any line obviously will sum to an even number. Now, how do we create an even number from the sum of odd digits? Well, you're always going to have an even number of odd digits on any line. So the number of odd digits on any line will be 2, 4, 6, 8, etc. That's going to have to be true. So for example, if we look at this Z-shaped line here, that must have, it can't have 4 odd digits on it. It can't have 0 odd digits on it. So it must have 2 odd digits on it, which will therefore sum to an even number, and 2 even digits will obviously also sum to an even number. Now, what about that line then? So that line is going to also have to have an even number of odd digits. So that has 2 odds and 1 even on it. Yeah, so we do know the parity of that cell. Because what this Z taught us is that any 4-cell line in this puzzle contains 2 odds and 2 evens. So this horseshoe has 2 odds and 2 evens. This 4-cell Tetris piece has 2 odds and 2 evens. How many odds altogether are there in any box of a Sudoku? Well, because of the rules of Sudoku, we're going to have the digits 1, 3, 5, 7 and 9 in that box, so 5 odd digits. So that is odd. Now, I think I meant to use orange for odd. Orange and blue. Blue for even, simply because, well, orange for odd because it begins with O. Blue for even because orange and blue in our palette are the most colourblind friendly combination apparently, so that is what we've grown up with. So this combination is 1 odd and 2 evens. 1 odd, 2 evens. And that combination is 2 odds, 1 even. I don't know. It's probably something to do with either row 1 or box 9 would be my guess. Well, probably because each of those essentially includes all the digits 1 to 9 plus things that stick out. And this includes all the digits 1 to 9 plus 2 digits that stick out as well. So, okay, let's try this box. It looks more friendly than this. Let's try this box. So that line has 2 odds and 1 even. So this line has 3 odds and 3 evens on it. So that is not the correct number of odds, because that's an odd number of odds. So this line is 1 odd and 1 even. Oh, this isn't going to do it, is it? Is it? I'm wondering if whether I might do this actually. This is perhaps frivolous, but I'm going to actually label. This line is 2 odds. Oh, it won't let me. Oh, if I press that, it might. 2 odds, 1 even. This line is 3 odds. and 3 evens. This is 1 odd, whoops, not 1 odd and 1 even. This line must have an even number of odd digits, so it can't have 4 odd digits, because the minimum number that 4 odd digits would sum to would be, in fact, 1, 3, 5, and 7, which is a lot more than 1 even digit can sum to. So this is going to have 2 odds, and oh, that's something. So this has got 2 odds and 3 evens on it. So all of the even digits in box 6, there are only 4 even digits in Sudoku, 2, 4, 6, and 8, have to be on the lines. So those 2 digits are also odd. So this is 2 odds, 2 evens. This is 2 odds, 2 evens. This is 2 odds and 2 evens. This is probably totally unnecessary, isn't it? That one is 1 even and 2 odds. This is another 2 odds. Oh, that's 2. That's okay. That's a 5-length line. Again, it can't. It's the same as this, isn't it? So all the lines, effectively, all the lines at least that I've studied so far, we sort of know what they contain. This one is going to be, it's another 5-length line, so this is 2 odds, 3 evens. That one is a 4-length line, so that's 2 odds, 2 evens. Whoops. That's 1 even, 2 odds. Okay, so it is this top thing, isn't it? Well, unless I've missed some subtlety down here. Well, that's definitely even. The whole of the top row has got 5. Well, there's a Sudoku secret. I don't know if it will be the secret. It might be. Should we try and do it without the secret and then back into the secret if we need it? So the whole of the top row contains 5 odds and 4 evens. So once we add this digit to that, that is an equal number of odds and evens. But it's still the wrong number of odds, because there's 5 odds in the top row. We know each line individually contains an even number of odds, so the 2 lines together should have an even number of odds. And the only way that can be achieved is if that is odd. Now, so that's definitely even. That's our first blue scale. I could have done it right at the start. And it's going to be something to do with how many odd digits you can put on these lines, isn't it? See, this line, how many odd digits are on it? Just look at this line. I'm not looking at this line. I just want to look at this line. That's a length 5 line. It can't possibly have, although it could have a repeated digit, even if those were both 1. No, it doesn't work. 1, 3, 5, which would be the minimum we could put on if we decided to try to put 4 odd digits on this line. It's actually much closer than I realised, but they do sum to 10, and I can't write 10 into a Sudoku cell. So this line has 2 odd digits on it, which means it has 3 even digits on it. So the minimum sum of 3 even digits would be 2 plus 4 plus 6, which is 12. Okay. Okay, but this line then has 4 odd digits on it. Because that one, if it's only got 1, there's only 1 odd digit in those 4 cells. So there are 4 odd digits in those 4 cells. So the minimum sum of 4 odd digits would be 1 in the same row, so we can't repeat, is 1, 3, 5, 7, which is 25 minus 9. Don't ask me why I do it that way. I have no idea. 16. Oh, that's lovely. That's it then. Yeah, that's it. Because this line Therefore, that's what it must contain. Because this line, remember, it only has 2 even digits on it, because this has 3 even digits on it. In the top row, there's 4 evens altogether. So there's 1 even in those cells, a second even here, that we've just worked out have to add up to a minimum of 16. Well, that means they have to be 2 8s. That's lovely. So that has to be 8, and there has to be an 8 in one of those 2 cells. And the odd numbers, which these are all definitely odd, are 1, 3, 5, 7. These are 1, 3, 5, 7, and 8. And this line, we know its makeup. It's got to be 2, 4, 6, 9. And that digit, therefore, to equate them, is a 3. Because we know that the evens on that line add up to add up to 12. Okay. So now this line's got... So, yeah, okay. So this is odd as well now. If we think about this box, we need to find 5 odd digits altogether. We know this line only has 1 odd digit on it maximum at these 3 cells here. That's a second odd digit. There's 2 odd digits on that line. So that has to be odd, and the 9 actually has to be in that string. So the 9 is not there. This is definitely even. I don't know if this odds and evens thing I've been doing is actually proving useful, but so 8, oh, okay, so 8 is on that line as an even digit. And 9 is on those cells. So, okay, so there are 2 even digits on this string. And the minimum they are now summing to is 10. I'm going to have to get rid of this. I keep thinking this line's got 2 on it, which it might have, but it might not as well. So these add to 10. But the odd digits on the line don't include 9. So do they include 7 is my question. If they didn't, no, they must include 7, because otherwise they're just 5 and 1, and that doesn't even add up to 8 before we add the second even digit. So there is a 7 on this line. And okay, so the other odd digit must be 5, because if it was 7 and 1, they would only add up to 8, and yet I've got to put a second even digit on it. So it's this line, we know its contents. It's 5 and 7 and 4 and 8, each adding up to 12, which means this digit is a 4. This is just beautiful. It's absolutely beautiful. And this is a 1 by Sudoku, which is a nice surprise. These don't include 8. That's very exciting, and hopefully I'm now going to work out something that follows from this. Yeah, I've got to get rid of some of these. I might not get rid of this one because it looks like this is where we have to go next, but I think I understand how 4-cell lines work, so I'm going to get rid of that. Now let's right, I see. I'm actually changing my mind. That 3-cell line has 2 odd digits on it, and it has 1 even. But that even is not 8 and it's not 4. It certainly can't be 2, because you can't sum 2 odd digits to 2. So it's 6. And the 2 odd digits that add up to 6 are going to be 1 and 5, because they can't be double 3. So that's a 1, 5, 6 line. So these digits don't include 1 or 5. This digit doesn't include 1 because of Sudoku. That's done remarkably little. There's a 2 in one of those. Okay. Oh dear. All right, so maybe it's not this box then. I was thinking it was going to be this one, but maybe that was... Okay, what's the minimum sum of 3 even digits. 2, 4, 6 is 12, isn't it? So there is definitely no 1 on this W pentomino, because we couldn't accompany the 1 with a high enough odd digit. It would have to be accompanied by an 11, which doesn't exist in the puzzle. So 1 is in one of those 3. Let's change the shading. Let's do that shading. 1 is in one of those cells. Now, I don't quite know what to do with this, I have to say. Oh, I see. It's not this box, is it? It's this. Right, I didn't think of this, but okay, that's fine. This is quite smooth, actually, this line. What's the minimum odd digits it could have on it? It's got to have 2. So it's got to be 3, 5, adding up to 8, doesn't it? Aha. So that's not... it didn't do nearly as much as I thought. I'm going to get rid of that. I'm going to get rid of that as well. Tell you what. This being 3, 5, 8 means I actually know exactly what these digits are. So they are... Well, I mean, obviously I know what they are. But they are 1, 2, 4, 6, 7, 9. Now, what does that mean? What's the total? So the total of the evens is 12, and the total of the odds is 17. So these digits have to differ in value by 5, and they include an odd. That's right, isn't it? So if I do put 1 on there, that would be 18 versus 12. Yeah, so this would be a 1 and a 6, so they differ in value by 5. Oh, I see. That's very helpful, because this can't include a 3 because of Sudoku. So it can't be a 3-8 pair. And once we go up to 5, we can't make it a 5-10 pair because 10 doesn't exist in the puzzle. That's lovely again. So this is 1, 6. This is not 1. These don't include 1 and 6 now. That doesn't include 6. Oh, right. Look at those cells. Give them a different colour. They are 2, 4, 7, and 9. 2, 4, 7, and 9. So that's definitely not 4. It's definitely not 7. So this is 5 or 8 on this line. 3 is in one of those cells by Sudoku. 8 is in one of those 3 cells. So this line here, which remember that that's quite interesting, because that line includes 3 even digits, one of which is now an 8. It doesn't include 6. Oh, so okay. Right, sorry, it doesn't include 6. That's the point. So we actually know we know everything about this line. We know it includes 8, 2, 4, which is 14. So it must have 5 and 9 on it to make the maths work. So let's just delete everything off this line. It's 5, 9, 2, 4, 8. Oh no. So 3 is there. 3 is not on that line. 7 is here. So if this is a 4, this is great. Come on, keep. Okay, let's just see if we can. Let's just see if that works, doesn't it? It felt correct as I did it in my head. We know that one is 5 or 8. We know these don't include 5 or 8, or 4 for that matter. So this is a 2-9 pair, and that's a 6 at the top of the grid by Sudoku, of all things. So these don't include 2 or 9 now. That looks like a quadruple. 4, 5, 7, 8. So these don't include 4 then. Or 7 for that matter. So we've got a sort of quadruple in column 8, which is a 1, 2, 6, 9 quadruple. And yeah, okay, I'm sure this does something. I don't know what it is, but these don't include 4 anymore, so they're 5, 7, 8. These are 4, 5, 8. So there's a 7 in here, and there's a 4 in there. Does that help us? Don't know. Wow, okay. It's quite interesting as well, isn't it? Because now I look at the puzzle and I'm aware that we're going to have to do something in these boxes, obviously, unless it's Sudoku that's meant to come to my rescue. But it is not obvious to me where the weak point is. Where do you attack? Which of these lines is under pressure is what I mean. Doesn't look like any of them are particularly under pressure. That line might have to have a 1 on it, I'm going to claim. Because again, we're adding 2 odd digits together. And if we didn't include the digit 1, it would have to be a 3, 5, 8 line, and that would break this cell. So there is a 1 on this line. So it's 1, but it could be 1 plus 3 equals 4, it could be 1 plus 5 equals 6, it could be 1 plus 7 equals 8. We know this isn't a 1. Can that be a 1? That would be a 2 on across the consecutive digits. Doesn't look impossible, does it? Wow, okay. Golly. I really don't know where to look. Am I being very dense here? I probably am. Oh, no, I am. I actually am being dense. Ah, right. Okay, here's a beautiful point, and it does use the secret, so I am going to have to share that secret with you. Something I share with only my very favourite people, but of course, if you're watching this video, I will share it with you. See this box 5, indeed any box of a Sudoku, any row, any column of a Sudoku. Because the rules of Sudoku tell us that those units, that box contains the digits 1 to 9 once each, if we sum those digits, we get 45. Now, what are the even digits on these 2 lines? They're 2, 4, 6, and 8. We know that, because this isn't even. So that adds up to 20. So what are the odd digits on these lines going to add up to? If the even digits add up to 20, the odd digits are going to add up to 20 as well. So that these 8 cells add up to 40, but the whole box adds up to 45. So this is a 5. That's absolutely lovely again. So that's 8, that's 4, that's 5. That's just Sudoku. That's 5. That's all done. That's 7. That's 8. Beautiful. That's 6. Oh, this is actually going. 5, 1. Okay, let's get rid of the accoutrement that we've added. This line doesn't have 8 or 4 on it, but must have 2 even digits on it. Because it's only got 2 odd digits on it. So they are 2 and 6 adding up to 8, which means we need a 3 there. So this is 2, 3, 6. This is 1, 9 adding up to 10. So these 2 digits are even and add up to 10. So they are 2, 8 or 4, 6 in that order. So this line has 3 and 7 on it, and we know where the 3 goes. So it's 3, 7. And again, actually, maybe I don't pencil mark that one. It's because it's got either 4, 6 on it or 2, 8 on it. I'll definitely note it's got 7 on it. That seems a reasonable thing to do. This line it's got to have an even digit on it. Yeah, that's helpful. The even digit on here can't be a 4 because it can't be. I can't have the odd digits as 1 and 3 for many reasons. There's a 3 on this line, 3's here. So the even digit on here is 8, and I know because it can't be 2 or 6. These two digits therefore have to be 1, 7 to add up to 8 without using a 3. So, oh, right, and that makes this 4, 6, because it can't include 8 anyway. It's lovely, this. It's absolutely lovely. 6, 1. In this row, this is a 9. Can't be a 2, so they all get filled in. This is now 7, 2, 8, and we know. And this is 5, 4. Adding up to 9. And that line, remember, that's got to have 2 odd digits on it. So it's got to have 3 even digits on it. This line might be worth thinking further about. I just want to check whether I can do any more Sudoku quickly. You are nearly. Actually, I can. Where's 4 in column 4? Now, where 4 is not is on this white dot, because it's consecutive with 3 or 5, which have both gone. So there is a second 4 on the W pentomino here. And that is no longer a 4. And this column, right, here is a weird point, but it's rather good, I think. Look at column 4 and look at the white dot. Now, the nature of consecutive digits is that one of the digits must be odd and the other must be even. So I want to think about what the odd digit is that's going on this dot. It's clearly not 1, actually. It's not 1, 3, or 5. So it is 7 or 9, which are going to be consecutive with 6 or 8. But 6 isn't unavailable. So this has got to have 8 on it with 7 or 9. And because it's got to have 8 on it, that top digit is now a 7. And that's an 8 by pencil marking. And that's an 8 by pencil marking. And that's a 7. And that's a 2. So this is an 8, 9 pair now at the bottom of the column. Those digits are 2, 3, 9. Somehow that's not resolved, which is ludicrous. That's not 3. Oh, my phone's going crazy. Now, do we know what this is? I don't think that can be 8, can it? If that's 8, the 3 even digits on the line add up to 16, but the 2 odd digits include a 5, so we'd need an 11. So that's got to be 9, that's got to be 8. Now this line has got a 1 on it, apparently. Is that really true? Oh yeah, we did that really earlier, didn't we? So that's 817. I did that by thinking about whether this cell this cell would be hampered by a 358 triple. So now this isn't 8, and this isn't 7. And this line, its 2 odd digits add up to 14, so its even digits add up to 14, and it's got 8 on it at the moment, so that's a 6. That's just beautiful. So this is 5 or 7 by Sudoku. Oh, not really Sudoku, by consecutiveness. I could probably do. Oh, I see. Now I can. This sort of U pentomino here, it's got 3 evens on it, but it doesn't have 6. So those evens are 2, 4, 8. They add up to 14. So the 2 odd digits that add up to 14 have to be 5 and 9. And they are the only combination of odds that do that, because you can't double 7 it. So we know exactly what this has got on it. And we know where the 8 goes by Sudoku. We know that's not 9. We know that's not 9. And if this has got 5 on it, that is now a 7. This is a 1-3 pair in the box, and I know the order of that as well. This is great, isn't it? Now, right, now we can start tidying up box 1. That's going to have to be a 1, that's 3, that's a 5. So these don't include 5 anymore. This doesn't include 3 anymore. 2, 4, 6, 9. So this digit is 2, 4, or 9. So the 6 in this column. Oh, yeah, the 6 in box 1 is placed, so that's a 6 now. This is a 2 or a 9. It's can't. Oh, where's 9 in row 2? We can ask that question, and we seem to get an answer. That gives us the 2 and the 3 there. These are now not 2, so that's a 4, 5 pair in this column. We haven't put 7 in. This looks like it's a 4, 9 pair as well. Those don't include 9, so this is a 2, 3 pair. This 9 here is lovely. So 9, 1, 1, 7. 7. Forgot to put 7 into box 9. I should do that, therefore. This isn't 9. Now, what should we do with this? 4, 4, 5, 9 in there. I've almost done all the lines, you know. I mean, I might not have done all the Sudoku, but I think we've done all the mathematics of the lines. There's a 2, 9 pair in column 9. So that corner digit's a 4, which, that's good. So that's 4, that's 2, that's 9. That should tidy up, I think, the first 3 columns. Yeah, and it did. That's now become a 6 somehow. So this is a 1, 2. Oh, this is a naked 2. 2, 9, 1, 9, 2, 8. Yeah, this is still going. I'm still okay here. Now, what do I need there? 2 and 5. Yep, 5, 2, 2, 3, 3, something, 6 probably. That's phenomenal. That is a phenomenal puzzle. Now, actually, look, we should do this, shouldn't we? I think we should. And 4s, 2s, 6s, 8s, they should be even. It looks like I didn't click 3s. Yeah, it felt, I mean, that really did feel like about as smooth a puzzle as we've had on the channel in quite a while, and it was gorgeous. Gorgeous, Jonesy. Absolutely loved solving that. And it wasn't trivial, it was just interesting and clever. Really, really lovely. Let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.